Hi, welcome to this session on taming your data monsters with Spring Boot and Azure Cosmos DB for planetary-scale database Bliss. My name is Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. Our time together today is very short, so if you have any questions, comments, or feedback, please do reach out to me via email or better yet, via Twitter or Mastodon at mkheck. So a bit about me. I am an architect and developer by trade. I am also obviously a principal cloud advocate here at Microsoft. I solo authored a book called Spring Boot Up and Running, Building Cloud Native Java and Kotlin applications. So you might gather from that, I am a Java champion and a Kotlin developer expert. And just for fun, I'm also an instrument-rated licensed pilot because everyone needs a hobby, right? So what's on the agenda today? First, we're going to discuss Spring Boot for enterprise Java development. Then we're going to talk about database options supported by Spring, and there are many. So it's very nice to know that you have good options and that in many ways, it's good to help refine those options to make better choices. We'll start with a demo when we get into the demoing using a local development database because although there are various permutations, as developers, most of the time we work locally in some fashion or another. And then from there, we'll go to a demo with Azure Cosmos DB and see how easy it is to scale from dev to prod. We will then summarize with just some links and some more information and what have you. So first, Spring Boot really does dominate the enterprise Java space. The Java ecosystem is absolutely huge. And Spring Boot, the smallest number I've seen is that over 57% of all Java developers use Spring Boot. And depending on who you listen to, that may be significantly higher. Why? I guess that's the first question. If you're not already using Spring Boot, you may be questioning, why am I not? Well, Spring Boot has a very developer-first focus. When you're new to Java development, or any development for that matter, there are many cases that you run into that there are a lot of steps that are involved to do a particular task. And the first time you do that, it seems very onerous because you're new, right? And you're learning to do this. So there seems like there are a million steps to do one thing. After you do that 2 or 5 or 10 times, you start to realize that, wow, this really is kind of, this is a lot, right? And it seems like there are a lot of steps here that I'm doing that are repeating themselves with 0 or very few changes between different times you're doing the same task. After you do that 50 or 100 times, you kind of become numb to it. And then it just seems like that's the way it has to be. But the Spring Boot developers took a different tack. They looked at patterns that formed. And when you see the same thing happening over and over again with little or no variation, that's easily isolated into a pattern. And that's where things like auto configuration come into play because it makes your life as a developer easier. It bends the framework around you versus you having to bend around a particular framework. So auto configuration is one example of that. And auto configuration is employed by Spring Boot applications at build time and at runtime to evaluate what you have in your application. So whether it's dependencies on your class path or your code or annotations or properties you set or beans you create in your application, all of these things are taken into account by the application either, again, at build time or startup, so that sensible defaults take place and sensible conditions are met, either positively or negatively. One example is that if you have a database driver on your class path and you define a data repository in your code, it kind of follows that your application should connect to a data store, right? And this seems very obvious. And of course, each time you connect to a database of some kind, you'll need to open that connection. And then when you're done, before your application closes, you'll want to close that connection. So why do we do this as developers? Why do we do this manually? Your framework should support that. If each time you connect to a database, it has to make a connection and then close the connection in around everything else that you need to do, why doesn't it handle it for you? And of course, Spring Boot does. So things like that roll all together to make auto configuration work for you. There's also simplified dependency management. So in typical Java fashion in the past, and even in some circumstances in today's climate, you will have a long list of dependencies that you'll have to incorporate to do a particular, maybe it's a very complex task, but it's still a task. And Spring Boot elevates the focus from dependencies to capabilities. So for instance, if you're developing an application that you need to use to expose a web-based API, you'll want to listen on a particular port, for instance, and take requests, accept requests, process them in some way, and provide responses. And all of those things work together. So by elevating the focus to a capability, all of the libraries that are necessary to perform those tasks as one unit are brought in and version synchronized and tested together. You can override those, you can change those out, but 99.99% of the time you don't need to, and therefore you just know it works. Simplified deployment is another feature of Spring Boot, because out of the box, you have the ability to deploy things as an executable jar, for instance, to the Java virtual machine environments. You also have the ability to create native images, native code, container images, and all of that is baked in and very simply done. So it simplifies your process of getting to production. Standards are supported, so long-standing Java standards, as well as those that are coming onto the scene currently and will be, as well as gaps in perhaps things that are addressed by the Java specifications, but are frequently used and demanded by Java developers. So Spring Boot kind of covers all of that, and I like to think works hard for you. Spring Data works similarly, and as I like to say, it works with everything. And there's probably something out there that if you come up with a new database today, maybe you don't yet have drivers for it, but chances are if it's a relational database within a couple days or a couple weeks, you're going to have JDBC, Java Database Connectivity drivers. You're going to support JPA, the Java Persistence API. If you have a NoSQL database, you're going to want that to work with Java, among other top tier programming languages. Spring Data has support for that. Again, out of the box, several different NoSQL databases of different kinds. So everything from graph databases, key value, wide table, document-based, in-memory, persistent. It's just in there. And of course, the ability to add more comes quite easily as well. There are different layers of abstraction. So whether you want to work directly with the data store or more likely a template-based API or even a repository-based API, which provides a very clean abstraction for most of the things that we do as developers on a daily basis. Blocking, non-blocking reactive APIs are provided as well. So it, again, like most things, it just works. So a bit of demo now, because I like to kind of show things in action. Before I show the action, though, I want to show the setup, because this is a very intentionally streamlined application that I've created in Spring Boot to work with, in this case, MongoDB locally and Azure Cosmos DB for MongoDB in the cloud. Now, I also have another example out there using Azure Cosmos DB for Postgres. There are many others. I have another one that I haven't actually committed to GitHub yet, but will shortly. And what I want to do is build out a portfolio that shows just how dead simple it is to develop robust, production-ready Spring Boot applications using Java that you can develop and iterate through and refine locally and push to production and scale globally. So a quick look at this. Again, this is intentionally very, very simple. I just added a couple of dependencies here. So I have the Spring Boot starter for MongoDB. I have the Spring Boot starter for web that allows me to build web-based APIs. And then if I look at our application properties, this is where your sensible defaults come in. And if you define certain properties, you can override those defaults that Spring Boot and Spring Data and all the other Spring projects take for granted. So for instance, a data source URL, I'm not providing that here because I want the defaults of running and checking for a local database running on the default port, in this case, MongoDB, so 27017 if memory serves. It will look for that locally and find it and use that. If you want to override that, it's as simple as providing that value for a property here, or in other ways that your Spring Boot application will pull the environment and pull that in. I like to use environment variables, and I'll show you that in a moment as well. So a quick tour of this. This is our domain class, our person record. I'm using Java records here for our MongoDB-based example. And again, very simple. It's just the database ID, first name, last name, and address. And of course, in other genres, like with Postgres, I'm actually using using Java classes, and I think I use Lombok with that. I have another example where I'm not using Lombok and I'm just using the standard getters, setters that we create ourselves as developers many times. But you have options. As a developer, you have options. I'm defining a public interface here, a person repository interface. And this is a great example of both Spring Data's capabilities that we're exposing. This is a CRUD repository, exposing the capabilities to do create, read, update, and delete operations for objects of type person with an ID of type string. And I'm extending that here, and Spring Boot's auto configuration sees that I have a MongoDB database driver on my class path. It sees that I'm actually extending a Spring Data repository interface, and it makes those connections and creates a proxy bean for us to interact with our data store underneath without any additional code on our part, which is huge. We can extend that. We can define certain query methods and things like that, and follow conventions that make that very simple to use as well as using the native query language for whichever database we're using. But in this case, I'm, again, keeping it intentionally simple. I have a data loader class that just allows me to drop a couple of records in there. I clean up in case I have a run from before that I left data out there, add a couple of records, and then just return them in the log so I can see them. And then, of course, the controller is where I expose the web API. In this case, I just have a REST controller to return the objects in the form of JSON. I'm returning all persons and then searching for a person by ID, grabbing the first person that is returned from a query for find all, and then posting a new person. So again, very intentionally streamlined application. So let's take a look at how this works. I'm going to just do a Maven Spring Boot run and run this with no properties defined. And what should happen is the Spring Boot application will go and look for a local database to connect to. All right, so we're running this and we're getting the local MongoDB instance. I'm running this using Docker Desktop here on the Mac. But again, you can do this any number of ways. It's just looking for a local MongoDB instance exposed on the default port. And if I go to query this, just hit 8080 for the endpoint, then I can see that it's working. And I'm getting back the 2 records that I know are out there. So that's kind of a quick and easy test of that. Now, if I want to connect to Azure Cosmos DB for MongoDB, what I want to do is just show, let's take a look here. And you see that I've defined an environment variable here, Spring Data MongoDB URI. And Spring Boot also has environment variable and environment processing capabilities wired in. So if you define this in your properties, spring.data.mongodb.uri, it works just fine. But you also can override that externally at runtime. So here it translates the underscores to dots. It brings this in as spring.data.mongodb.uri, processes this, knows that I want to point to a data store out here on Azure, which is Azure Cosmos DB for MongoDB, and it will connect to that instead with 0 effort on my part whatsoever, which is huge. Talk about making it super easy to go from dev to prod. And here we see exactly that the address is now pointing to a cloud-based instance of our database. And then if I go back and just check that again, there we go. So that's super simple, right? We went from dev to prod with absolutely no headaches on our part. But what happens when it's time to scale? And that's where it really, really gets exciting. So I have the data store shown here, my Azure Cosmos DB for MongoDB. And I've already done a little bit of configuration on this because instead of just pointing to a single location, I have East US set for the right location, and I have East US and West US set for our read locations already. Now, that's just the start, as I mentioned. You can actually go here to replicate data globally, and you can see that we can set up various different write regions, read regions. We can set up availability zones. So even if within a region you have a failure, it seamlessly converts over and reconnects everyone to that the other location within that availability zone. You can enable multi-region writes so that you can have folks, if you have user communities here in Brazil and here in South Africa and here in Australia, and here in the US and Europe, you can have write capabilities as well as read capabilities, obviously, around the globe and the writes are automatically synchronized among them. So it takes the headaches out of that for you as well. You get global scale in a blissful way because the database does the work on your behalf. So we're almost out of time. I want to come back and just wrap up with a couple of things. Spring Boot gives developers superpowers, and I think you've seen a hint of that today. Very developer-first focus in terms of the application and database support. But Azure Cosmos DB takes your data from dev to prod and it scales it out around the globe. It's super easy to implement. It's super easy to manage. If you want to know more, here's the URL for the meta repo. I'll be adding that sub-repos to that as well. It's got a couple out there already. And if you want to know more about Azure Cosmos DB, because who doesn't, check out the links at the bottom. With that, I will leave you. Happy coding and have a great conference.